Okay. So this one here is going to be x plus 2 can't equal 0. X minus 3 can't equal 0. X can't equal negative 2. X can't equal 3. So x can't equal negative 2 or 3. C is a difference of squares. So on the bottom, you're going to get y plus 2, y minus 2. So your MPVs are going to be y can't equal plus or minus 2. So now we're going to go into simplifying. Now, whenever you simplifying, it'll say simplify for all of them. And then the operation you have to do, you'll see between the rational expressions. In this case, it just says simplify, and there are no operations because we're doing basic rationals. What you need to do, yeah, this is like it's a double-decker issue. There was 2 phone people. Put your phone away. It's still out. I don't care.
Still there for Lepp. I see it. Through his legs. I'm not playing on it.
All right. Example. Simplify the rational expression and state any non-permissible values. So your very first step when it says simplify, for just plain old simplifying, is you have to factor the top and the bottom. So you have to factor the numerator and the denominator. Because it doesn't just say state NPVs, right? You actually have to simplify now. So could you take out anything in the numerator in the top? A 3. And then you're left with x minus what? 2. The denominator is decomp. Always do your factoring. That's being recorded too. And now the volume comes back, and this is what this is. Awesome. Not true. Okay. So I always label these off to the side because what you're going to end up doing is you're going to be doing an extensive amount of factoring when we start doing multiplying and dividing and stuff. So I labeled that one 1. So I'm off to the side. I'm going to factor it. 2x squared plus x minus 10. And then you'd say, what times what equals negative 20? What plus what equals positive 1? What's it going to be? 4 and 5, but one of them has to be negative. 5 and negative 4. Can I go right to brackets? No, I have to decomp. So you go 2x squared minus 4x plus 5x minus 10. Do I have to do it in that order? 4 and 5? No, but it's easier. Okay, then we group them. Take a 2x out of the first one. You're left with x minus 2. Take a plus 5. We're left with x minus 2. So I'm left with 2x plus 5 and x minus 2. Just take out a 5. Okay. So we have 2x plus 5 in the denominator and x minus 2. Now, some of you are going to be super excited because you're going to see that there's 2x minus 2s. There's one on the numerator and one on the denominator, and they're going to be able to cancel, which is fantastic. But you have to state non-permissible values before you cancel. Because your non-permissible values are the values of x that exist right from the beginning to the end. And if we cross those off, we're going to cross off the 2. And remember, what did we do at the very beginning when we put that 3 in? It didn't work for all of those, even the trinomial, right? So we have to state all the non-permissible values, not the ones that are just left over when you're done reducing it. Okay? So before we go to cross off, slap your hand and be like, do not cancel until you state NPVs. Don't slap someone else's hand, just slap your own. Okay. So the NPVs I'm going to do over here. 2x plus 5 cannot equal 0. And x minus 2 cannot equal 0. Subtract the 5. 2x cannot equal negative 5. Divide by 2. X cannot equal negative 5 over 2. Add the 2. X cannot equal 2. Shh. So your two NPVs are x can't equal 2 and negative 5 over 2. Once your NPVs are written, then you can cancel off stuff that matches. Now, keep in mind, this is where I get the craziest answers ever. Not in a good way. Like super crazy and not completely right at all. So they have to match completely. Oh. They have to match completely. So if you have an x minus 2 in the numerator and an x minus 2 in the denominator, they can cancel. What if I had a 3 here and I had a 2? What if I had a 3 here and I had a 2x plus 3 in the denominator? Could I cross this 3 off with this 3? No. You can only cross off stuff that's the same in the brackets, okay? If you cancel off the wrong things and you cancel off too much, you're going to get no marks. So it's 3 over 2x plus 5, and then behind it you say x can't equal negative 5 over 2 and 2. Simplify the rational expression and state any non-permissible values. 2y squared plus y minus 10 all over y squared plus 3y minus 10. Okay, so you get 2y squared plus y minus 10. Well, you should have. Okay, 2y squared. So what multiplies give you negative 20, now it's give you 1. Positive 5y minus 4y minus 10. I'm doing it this way to prove that it doesn't matter which order you put it in, although this is not a very nice order. So you take out, I labeled it a 1. So you take out a y and you're left with 2y plus 5. Take out a negative 2 and you're left with 2y plus 5. So although this way works, it's much more confusing. So in the numerator, I have y minus 2. It equals y minus 2 and 2y plus 5. Now, we're going to have equal signs between each expression because this expression equals this one. It's not this expression equals some floating expression that doesn't have an equal sign, equals some other floating expression that doesn't have an equal sign. They equal each other, put equal signs. So, then number 2, I'm going to do over here. So, y squared plus 3y minus 10 factors into y plus 5 and y minus 2. So in the denominator, I have y plus 5 and y minus 2. No. So, where is this? Oh, there. Okay, so before we go to cancel, because we're excited because we see y minus 2 is on the top and the bottom, what do we have to remember to do? State the NPVs. So we'd have y plus 5 can't equal 0, and y minus 2 can't equal 0. So this one, y can't equal negative 5, and this one, y can't equal 2. If I plugged in negative 5 by itself, it would get me a 0 in the denominator, correct? And if I plugged in a 2 by itself, it would give me a 0 in the denominator. So you can check your NPVs as well. Now we can cross these off, y minus 2 and y minus 2. You cannot cross off the y plus 5 with the y plus 5 from the 2y plus 5. Bad. 2y plus 5 is only going somewhere if there is a 2y plus 5 in the denominator. Is there? No. If there is a y plus 5 in the denominator, it is only going somewhere if there is a y plus 5 in the numerator. Is there? No, nothing's going away. We're left with what we're left with. 2y plus 5 over y plus 5. To be honest, the problems I find is not the not canceling enough. It's too much canceling. You like get cancel happy. Don't do that. We're going to ignore this one for now. We're going to look at these three. Go. Okay. So up here, it factors to x plus 1 and x minus 1. In the bottom, it factors to x plus 2 and x plus 1. Before we cross off the x plus 1s, we have to do what? The NPVs. So we'd have x plus 2 can't equal 0. X plus 1 can't equal 0. X can't equal negative 2. X can't equal negative 1. So x can't equal negative 2 and negative 1. Then the plus 1s cancel. Can this x cross off this x? No. X minus 1, is there an x minus 1 on the bottom? Is there an x plus 2 in the top? No, so they stay. Do I need to have them in brackets anymore? No, I just really felt the need to do that. But they don't have to be in brackets. Whoa! Chord is awesome. Okay. Shh. Okay. Bottom left. I could take out a 2x, someone said. So you're left with x squared minus 2x minus 15. Now the 2 and the x, do they have to be in separate brackets or can they be together, or what can we do with the 2 and the x? They're separate because they are multiplied. Then on the bottom, what can we do? If we take out a 4, what are we left with? Is x squared minus 5 a difference of squares? No. 5 isn't a perfect square. I knock this out every class. No, that's the cord to the speaker. Okay. So when we go to state NPVs, we can still state NPVs for this, but we can't factor it. So the 4 isn't going to get us an NPV, but the x squared minus 5 will. So we go x squared minus 5 can't equal 0. We have to take the whole thing because we can't do difference of squares. Add our 5 over, and we get x squared can't equal 5. Take the square root, and what do we do when we take the square root? We get a x can't equal plus or minus square root 5. Because when you take the square root, you need the positive and negative. The top we can keep factoring, so we can go 2 and x, and then we get x minus 5 and x plus 3. And then the bottom we get 4 and x squared minus 5. Is there anything I can cancel off? The 4 and the 2. This x squared minus 5 staying, the x is staying, the x minus 5 staying, the x plus 3 staying, because there's no copies, cats of those on the top and the bottom. But the 4 and the 2 I can take out a 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. So it's going to be x minus 5, x plus 3, all over x squared minus 5. X can't equal plus or minus 5. There is a trick to the last one here. So x squared minus 81 is a difference of squares. In the top, you're left with x plus 9, x minus 9. And in the bottom, you have 9 minus x. So to state NPVs, we go 9 minus x can't equal 0. 9 can't equal x. I can just move the x over instead of the 9. Yeah, I forgot the 2. Okay. So we have 9 minus x, and we have x plus 9, x minus 9. So this technically means I have a positive 9 and a minus x. Is there anywhere in the numerator where I have a positive 9 and a minus x? No. But what could I do? Yeah, I don't know why I keep dropping that off. Okay. What could I do to the denominator here? You could take out a negative 1. This is a positive 9 and a minus x. I have a positive x and a minus 9 in the top. They're the exact same but wrong signs, correct? So if I take a negative 1 out of the bottom, then they'll be the right signs. So it's x plus 9. So if ever you have the right terms but wrong signs, you can take a negative out. So I take a negative 1 out. I'm left with negative 9 plus x. Is there a negative 9 plus x in the top? Yeah. X minus 9 is positive x minus 9. Minus 9 plus x is minus 9 plus x. They match. So they can cancel. And what can I do with the negative 1 in the denominator? What can I do with negative signs? You can move it to the top. I just took a negative 1 out. You can take a negative 1 out of anything. Yeah. You can't take like a negative 2 or anything out, but you can take a negative 1 out. If you don't take the negative 1 out, then you can't cancel them. I'm recording and I'm answering a question about the question, so it's okay to record. You can just take a negative